Hello my dear students, welcome back to my channel Essential Academy Chemistry with Vinay. In this video, I am going to show some of the important questions that is going to be based on SN1 and SN2 mechanism. In my previous video, I had shared a super trick box about the SN1 and SN2 mechanism. Now in this video, I am going to show you how to make use of this super trick box and solve the questions. Children, you can solve all kinds of questions based on SN1, SN2 mechanism where you really need to know how to recognize whether it is an SN1 or whether it is an SN2, which will undergo faster SN1, which will undergo faster SN2 mechanism. Then let us start with the number of questions one by one and let us understand how to make use of this trick box. The first question we have here, I'll pick the first question for all of you. You can observe the first question. In this first question, if you observe children, which of the following will react faster through SN1 mechanism? If you observe in this, the option A is a secondary alkyl halide. If you observe this is a aryl halide, it does not undergo SN1 mechanism. If you observe here, it is again an example of an haloarene where it also does not undergo SN1 mechanism. Whereas here it also undergo SN1 mechanism. This is an example for allylic halides. In case of allylic halides, it is because of the carbocation will be very near to the carbon atom where there is a resonance effect, due to which this carbocation will become more stable and it shows a faster reaction towards the SN1 mechanism. Therefore, option B is the correct answer. Remember children, whenever you come across an allylic or a benzylic halides, it undergo very fast SN1 mechanism than tertiary alkyl halide, secondary alkyl halide and primary alkyl halide. Hope you have understood this question. It was from the NEET 2017. Let us go for the next question now. This is a very interesting question children. Here it is. If you observe here, this is a question of NEET 2016. Let us see what is this question is. Consider the reaction. So we are considering a reaction where it is a secondary alkyl halide. Yes, it is a secondary alkyl halide. Then in the presence of sodium cyanide, it undergo a reaction. Now the question is, this reaction is what first? Let us see how to use the trick box now. You can observe here a secondary alkyl halide is here, and how it is going to undergo in the presence of, this is a strong nucleophile children. Yes, it is a strong nucleophile. Yes sir, yes it is a strong nucleophile. You can observe here, I'll add here NaCN. NaCN. Yes, it is a strong nucleophile. You can see CN, CN, CN. It is a strong nucleophile. Definitely it undergo SN2 mechanism. Yes, therefore this the above reaction undergo SN2 mechanism. For an SN2 mechanism, which is the best solvent? If you observe the options, what they have given is the solvent. So what are the solvents that is better for the SN2 mechanism? For SN2 mechanism, if you observe, the best solvents are, you can observe here, that is polar aprotic solvents, that is dimethyl sulfoxide and dimethyl formamide and acetone. So here NN dimethyl formamide. So this is the best solvent for this above reaction. Hope in this kind of question where you need to recognize first what type of a mechanism the above reaction will go, and then you can easily find out the solvent. So option A is the correct one. I am sure you have understood this question. Let us quickly go for one more question. In this question, if you observe children, it's a very easy question. You can do it. Which of the following alkyl halides are hydrolyzed by SN1 mechanism? So in this question, if you observe, this is also going to undergo, this is a primary alkyl halide, a secondary alkyl halide, this is a secondary alkyl halide, whereas this one is a tertiary alkyl halide. So how to make use of the trick box? It's very simple. You can observe here. For an SN1 mechanism, the order of reactivity first comes tertiary alkyl halide, then comes secondary, then comes primary. Therefore, tertiary is the one which will be undergoing very fast SN1 reaction. So in this is the option D, is the tertiary alkyl halide which undergo SN1 mechanism very faster rate. Hope you have understood even this question also. Let us go for one more question. Yes, I am sure you will do it. You can just pause the video and you try to solve this question, children. Yes, you can do this question. Sir, what is this based on? You can observe here. Which would undergo SN2 reaction faster? This question is based on in this part, that is nature of leaving group, children. So in the nature of leaving group, whenever there is an iodine, that undergo very fast SN2 mechanism. It is going to undergo a very fast SN2 mechanism. So which one is going to be faster here? Yes, you are right. Option D, where iodine a better living group than the other chloride, bromide and fluorine. Therefore option D is the correct answer. Yes, let us go for the next question. That is very interesting one. Definitely you will do this question. And the question is, you can observe here, it is an example for a benzylic halide, children. Yes or no? Yes, it is an example for a benzylic halide, where a halogen is attached to a carbon containing single bond. The other carbon has been attached to a benzene ring. Yes, it is a benzylic halide. In the presence of aqueous NaOH, children. Say if it is only NaOH, it used to be SN2 mechanism. Whereas in this question, if you observe, they have given aqueous NaOH diluted. And always remember, as I mentioned, all the allylic halides as well as benzylic halides, they always prefer SN1 mechanism because it is an benzylic halide and it is an aqueous NaOH. It is a aqueous NaOH and it will always undergo SN1 mechanism. I hope you have understood this question. Let us move for the next one more question. We have a very interesting one now. I am sure you will do it very soon. You should be very much careful in this kind of question, children. If you observe here we have a secondary alkyl halide. Yes, sir, this is a secondary alkyl halide. This secondary alkyl halide, in the presence of a it is a weak nucleophile. Yes, sir, it is a weak nucleophile. You can observe here. Yes, it is a nucleophile which is a weak nucleophile. Definitely it will help for SN1 mechanism. And if you observe the solvent which has been given here, water with acetone, you can observe here it is water with acetone is a protic, polar protic solvent. Always remember, water with acetone is polar protic, which prefers SN1 mechanism. If it is only acetone, polar aprotic, that prefer SN2 mechanism. So in this question, if you observe, there is a strong weak nucleophile, and there is a polar protic solvent. Definitely this secondary alkyl halide will undergo SN1 mechanism. I hope you are understanding how I am making use of this trick box again and again. We have the final one, the last question, and that is, which one of alkyl halide show faster SN1 reaction? This is again based on the type or the nature of alkyl halide. So let us find it out which one is that. So if you observe in this, children, this is a primary alkyl halide. This is a secondary alkyl halide. And here we have one more. And here we have a tertiary alkyl halide. In this case, if you observe, this carbon atom is more stable than the other carbon atoms. It's because there are 3 phenyl, that is phenyl rings, benzene rings, which will show more resonance effect, due to which the carbocation stability will be more and it undergo easy SN1 mechanism. Hope you have understood this question also. Children, in SN1 and SN2, you need to memorize this chart very well. You should be able to recognize what is given as a weak nucleophile. Is it a strong nucleophile? Is it a polar protic solvent given, or is it a polar aprotic solvent? If you memorize this super trick, that is a box where you can easily solve all kinds of SN1 and SN2 mechanisms, easily you can do it. Hope this video was helpful for you. If you liked the video, please comment on the video and as well as subscribe to my channel for some more videos. Very interesting videos. I'm going to come again. I'll try to put all the things in one particular place so that it will be helpful for you a lot. That's it in this video. See you again in my next video.